So interval estimate. What is interval estimate? We are going to find the interval. Okay, to estimate the unknown parameter of the population, instead of finding the single value to estimate of unknown parameter, instead of finding the single value, the parameter is unknown, we are trying to find the parameter only. So instead of finding the single value of the unknown parameter, if we find two values between which the parameter may be considered. So between two values, suppose A and B, the parameter lies in this interval. We are trying to find the parameter lies in this interval. So we find two values between which the parameter may be considered to lie with certain probability. So certain confidence. Suppose 95% I am sure that the parameter lies, the unknown parameter lies in the interval A comma B with some confidence is known as the interval. This is known as the interval estimate of the parameter. And the technique of estimating is known as the interval estimation. The technique we are using now, that is known as the interval estimation. So this is known as the interval estimation. Sorry. The technique is known as the interval estimation. So here you will be getting the interval value, not point value, and this is interval estimation. Okay, to estimate the unknown parameter of the population. So ultimately what you are finding, to estimate the unknown parameter, that is to estimate the unknown parameter of the population, to estimate the unknown parameter of the population. The concept, okay, we are using the concept of theory of estimation. We are using the theory of estimation. Okay, so we are trying to find the unknown parameter. For that, we are using the concept of theory of estimation. Okay, there are two types of estimation, namely, what are the two types of estimation? Point estimation and interval estimation. These are the two types. Point estimation, when a single value is used as an estimate, it is said to be the point estimate. This is the first tick, okay, of the population parameter. In other words, an estimate of the population parameter given by a single number is called the point estimation, right? I am telling this again and again. For example, 55 is the mean mark. Suppose I am telling 55 is the mean mark obtained by a sample of 5 students. Okay, it's X bar. We are taking the sample of 5 students randomly drawn from the class of 100 students. So the population size equal to 100. There are 100 students and randomly you are drawing 5 students and you are calculating the mean mark. Okay, is considered to be the mean marks of the entire class. This 55 is considered as mean mark of the entire class. Okay, the 55 is the point estimation. What you are doing here is a point estimation. Suppose interval estimation, we'll see. 50 kg is the average weight of the sample of 10 students. We are taking average of 10 students is 50 kg, right? And the sample size we are taking 10 students, right? Drawn from the class of same, from the population sizes 100. So from the 100 in the class there are 100 students. We are taking 10 students at random. 10 students at random. That is my population size is 10, and their mean weight is, suppose it is 50 kg of the class of 100 students is considered as the average weight of the entire class. So the single value 50. We are getting the single value 50. Sorry, again this is the same example. The point. This is also the example of the same the, what is that, single value, so point estimation only. This is also example of point estimation only. I am giving the same example, right? So it cannot be given here. Okay, instead of considering the estimated value of the population parameter to be single value, we may consider the interval. We can say that their weight lies between, what we got is 50 kg. So the weight lies between 45 to 55 kg. Okay, population weight, the weight of the average weight of the whole population, 100 students. If I estimate like this, the weight lies between 45 to 55, then it is the interval estimate. I cannot get a single value here. It is an interval, right? So in interval estimation, we'll go back to the interval. The sample mean X bar is the sample statistic used as an estimation of population mean mu. Okay, suppose I want I'm using X bar. Okay, the sample mean X bar. X bar. What is my sample mean here? 55, no, in this example. The sample mean X bar is the sample statistic. Okay. Okay, sample, whatever characteristics related to sample is known as a statistic, sample statistic. So I am taking X bar, sample statistic. What I am doing with this, used as an estimate. I am going to estimate what? Estimate of population mean mu. Here in this example, I took X bar, that is a sample statistic. I got answer as 55. I am trying to estimate the population mean here. I am trying to estimate the population mean mu, right? So, this is what you understood about that. Okay, little bit you understood, I think, about the point estimation. Interval estimate. Now I will go to the topic of interval estimate. Again, we'll talk about the interval estimate. Interval estimation. Generally, there are situations where point estimation is not desirable. We are interested in finding limits. We are actually finding the limits which the parameter would be expected between this limit. For example, between this limit A, B, between this interval or between this limit, the population parameter is there. Between this limit, I am sure that the population parameter lies in this interval. How many percent sure? Suppose an example I am giving, 95% confident. This is one example, right? So the interval estimation, this is known as we are interested finding the limit within which the parameter would be expected to lie. It's called the interval estimation. For example, if T is a good estimator of theta. Okay, like X bar is a good estimation of mu. Same way, T is a good estimator of theta with standard error. Yes, okay, because we cannot say the exact answer. There will be some error. So we are accepting that error, that is known as a standard error, then making use of general property of the standard deviation using the general property of the standard deviations, the uncertainty in T So we are going closer to t, but it cannot be 100%, right? There is some uncertainty is there. That is standard error. We are talking about standard error, no? There may be error. Okay. Therefore, that is the reason we are using the uncertainty in t, right? There is some error. We are accepting there is some error. So deviations. So the uncertainty in t as an estimator of theta. Okay, we can express in the statement like this. Can be expressed in the statement. The following statement, I will express an example. We are about 95% certain that the unknown theta will lie somewhere between t minus 2s. 2s is what? Error. Okay, to t minus 2s and t plus 2s. Right? We are almost sure that theta will be in the interval, that is t minus 2s, t plus 2s. In this interval t will be there. Such intervals are called confidence interval. And is explained below, right? And such intervals are called confidence interval. So t lies between t minus 2s and t plus 2s. S is nothing but standard error. So somewhere t will be somewhere here. You can show that t will be somewhere. It will be somewhere here. Right? T lies between somewhere here. So t lies here. So how many percent confidence? Here it is given. I am 95%. I am sure that t lies between somewhere between t minus 2s and t plus 2s. Right? Now we go to the confidence interval. After obtaining, what is that? Confidence interval. Okay, after obtaining the value of t, that is a sample for a given sample, we can make some reasonable probability statements about the unknown parameter theta. This question is very well answered by the technique of confidence interval. Okay, let us take small value of alpha, and this is known as the level of significance. Alpha is known as the level of significance. What is alpha? Level of significance. Okay, alpha, the small value of alpha is known as the level of significance. It may be 1% or 5%. So you'll be surprised. Confidence in level of significance is 100 minus 1, that is 99%. Okay, this we got from 100 minus 5, 95%. Okay, here we talked about now 95%. We are 95% certain. Okay, 95% certain means 5% level of significance, we say. 99% certain means 1% level of significance, right? To determine the constants, say C1 and C2. Okay, that interval, no, C1 and C2, that is P1, C1 lesser than theta lesser than theta 2. This probability